welcome back to my channel. Today we are going to discuss group number 2 and mainly the physical properties actually and the chemical properties as well. But in chemical property we'll just going to discuss the general trend, not the each property that how do it react with certain like things, whether acids, water, oxygen, or how do they act as hydrides or hydroxides. We are not going into detail of that one, but we are going to discuss the general one. So the very first property when we talk about the physical property is the atomic size. Simple. So when we talk about the atomic size, we talk about the size of an atom. Now, when we move down the group, you must know why we add like what do these periods in the periodic table represent. They represent the shell number, or you can say the principal quantum number. So when we move down the group, there is addition of each shell periodically, definitely. So definitely the size is going to increase. So going down the group, this atom becomes larger because there is addition of principal quantum shell. And definitely if the size is becoming bigger, the nucleus has a lesser attraction for the outermost electrons. So the atomic radius of group two elements are like these, though. So these are in nanometers. So beryllium has almost 0.12, and you can see accordingly there is an increase in the size of these atoms. Then the next one is the melting point. That is also a very important one. So it depends upon like how easy, yeah, we just say how easy a substance is going to melt, or it depends upon heat, that what type of heat is required to actually remove the electrons or make the bonding really weak. So the melting point of the elements decreases down the group because when we talk about magnesium, the size is really small, or beryllium, the size is small. The atom has, or you can say the nucleus has a greater hold on the outermost electrons, so they are difficult to release. So they have high melting point. But when the sizes increases, the attraction of nucleus and the outermost electrons becomes weak, due to which they are easy to remove. That's why the melting point decreases down the group. Simple. The outer electron get further away and the attraction becomes weaker, so the melting point decreases. So these are the general trends. The beryllium has the highest one, around 1280-90, and when we talk about barium, it has around 700 degree Celsius. So and the melting point decreases down the group. When we talk about density, definitely the atomic mass, or you can say mass number, increases down the group, so definitely the density is. So down the group, the density of alkali earth metals increases. So these are like this is the graph that is representing it. So you can see an anomaly over here, that is due to the attraction of certain like structure, due to which density appears to be less, but in general the density increases down the group. So when we talk about the chemical trend, we first of all we need to keep in mind the ionization energy, because your chemical property is going to depend upon how easy it is to remove the electron. So if it is easy to remove the electron, definitely the reaction is going to be easy. So that's why the reactivity increases down the group, down because the last one atom, the number of shells are more, the shielding effect is more, there is lesser attraction of nucleus towards the outermost electron, they're easy to remove. So the ionization energy is really less, so the reaction can occur easily. But if we talk about these small size atoms, they are held with very strong electrostatic force, and the electrons are difficult to remove. That's why the you can say reactivity is quite less if the size is small. So if we talk about the chemical trend, we say that there are two outermost electrons as it belong to group number 2. So it can form plus dipositive ion, simple, with plus 2 charge. And it acts as a reducing agent because it's giving electron to someone. So how do we define reducing agent? First of all, the reducing agent is something that reduce others, not itself, but oxidize itself. And how do we define oxidation reduction in term of electron. Reduction is addition of electron, while oxidation is removal of electron. So as you can easily see over here that these are forming plus two ions, a dipositive ion. It means that um, they are giving electrons, the electrons are removed, so they basically get oxidized. So these are reducing agents, oxidize themselves itself but reduce others. So reactivity increases down the group, and we have discussed this in detail, that what are the reasons. Number one, the atomic radius increase. Number two, there is more shielding effect. There is less in nuclear attraction, due to which the electrons are easy to remove. Simple. Let's look into the trend of these one. So reactivity increases down the group because the electrons are easier to remove. They have increased shielding effect, more atomic radii. So if we look at the graph, now it is important to just understand this one. This is the light one is the first ionization energy, and the darker one is the second ionization energy. So definitely first ionization energy is less as compared to the second. The reason is quite like easy to understand. So there are, let's say there are 10 electrons for 10 protons. If one of the electron is removed, now we have 9 electrons with 10 protons. Now your positive or your nucleus is quite stronger as compared to these electrons. So it has more hold on these 9 electrons, because you can say that one extra proton is going to cover these 9 electrons now. So the second ionization energy would be really high, because it would become difficult to remove that electron. So you can observe in each case that the second ionization energy is higher as compared to the first one. So the general trend is that ionization energy decreases, and we have learned 3 to 4 reasons. So you must keep those in your mind and you can easily explain it. So these are not difficult to explain. You just need to have a basic understanding of consider yourself as an atom, and then you can easily judge or easily explain that why, how do atoms behave and why do they behave in a certain way. So this is all for this video. See you in the next video with more chemical properties. Stay tuned.